What's up, everyone? How are you all? Sean with Beyond the Bonds, and this is episode 10. We are going to talk about molecular geometry. Let's go. Molecular geometry provides us information about the three-dimensional structure of molecules. The 5 forms of interest that we will discuss are linear, trigonal planar, angular or bent, tetrahedral, and trigonal pyramidal molecular geometry conformations. Beginning with the linear conformation. Linear conformations have bond angles of 180 degrees, characterized by either diatomic molecules taking this form or molecules with 2 bonding groups and molecules with 2 non-bonding pairs of electrons. An example of a molecule with a linear conformation is carbon dioxide. Trigonal planar conformation has bond angles of 120 degrees. The central atom has 3 bonding pairs of electrons and 0 non-bonding pairs of electrons, making it an exception to the octet rule that we normally follow. An example is boron fluoride, or BF3. Angular/bent conformation has bond angles of less than 109 degrees or less than 120 degrees, depending on whether there are 1 or 2 non-bonding pairs of electrons. The central atom of an angular/bent molecule has 2 bonding pairs of electrons. An example is H2O, colloquially referred to as water. The tetrahedral conformation is characterized by bond angles of 109.5 degrees. The central atom has 4 bonding pairs of electrons and 0 non-bonding pairs. An example of a tetrahedral molecule is methane, or CH4, given by the green. The last conformation we'll talk about is trigonal pyramidal conformation, characterized by bond angles of less than 109.5 degrees and the central atom containing 3 bonding pairs and 1 non-bonding pair of electrons. An example is NH3 or ammonia. Implications for structure in 3D geometry is polarity and non-polarity, state of matter, boiling and melting points, and solubility. Polarity is characterized by differences in electronegativity and unsymmetrical molecular geometry, whereas non-polarity is the vice versa. State of matter determines whether the molecule or compound of interest will naturally exist as a liquid, solid, or gas. Boiling and melting points are characterized by how strong the bond between the atoms are and how much energy it takes to break the bond. Solubility is characterized by the principle of like dissolves like. Thus, polar molecules will dissolve in polar molecules and nonpolar molecules will dissolve in nonpolar molecules. This has been another episode of Beyond the Bonds. Please like, subscribe, and comment with your feedback. Thank you so much.